Dribble kill. Hey, don't we have a physics project due tomorrow? Do we?
We're building a trebuchet.
So today we are going to compare the velocity of our trebuchet launching a baseball and to Mr. Greg's larger trebuchet launching a cantaloupe. We're going to compare the initial velocities of the two.
3, 2, 1.
All right, go.
All right, test 1.
God!
Yeah!
Watch out. Can somebody run out there and find that?
Will, Chris, Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate. Will,
We are
Chris,
building.
Josh, Nate.
We are building.
A trebuchet!
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate. Will,
We are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We are
Will, Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
trebuchet!
Will, Chris,
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
Can we just
Will, Chris, Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate. Will,
We are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
Can we just repeat that, dude?
Will, Chris, Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
Can we just repeat that?
Will, Chris, Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
A
Josh,
trebuchet!
Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
Can we just repeat that?
Will, Chris, Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
Josh, Nate.
We
Will,
are
Chris,
building.
So here we are. We have the trebuchet packed in the trailer. And we are ready to move out. Right, Nate? Let's go.
All right, go.
Alright, so we built a trebuchet. And this is how it works. This is how it works. Yeah, Josh. Okay, well basically we have the support here so that we can stick this metal bar through it that the arm rotates on. And at one end of the arm we have the weight which makes it swing. And at the other end we have a net that has the ball in it that actually throws the ball. Alright, I'm explaining the release here, so go ahead and pull it down, Josh. As you can see, these two eye hooks are fixed right here, and then this third is fixed on the throwing arm. So pretty much I will slide this through, and that will support it. I'm gonna put this in. And then once I release this, the weight drops, and it flies up, and it throws it. Now the chute,
Where's the baseball at?
this right here, these two boards slanted in, keeps it steady and in a straight line so it doesn't wobble and fly off to one direction, and it keeps it straight. We're gonna dry fire it. Alright, we're gonna dry fire it.
I should actually fire it.
Come on. When it's not ready to fire.
Let's go, let's go.
Careful doing this because you could die.
Yeah, I can die.
Eyeballs. Watch all the heat involved in this.
All right.
Alright, 3, 2, 1. That's how it works. Let's try it out. Two, 1. Up. That looks like it's a little.
Go.
3, 2, 1. Yeah!
Yeah.
You get the.
If it came and flipped through that window from your house.
Yeah. Exactly. Right here. Woo! Hold on. I need to pull it more. Release it. Go ahead. Okay, it's about right. Feet? 96 feet. I pulled in. Ha-ha! You ready?
All right, go for it.
3, 2, 1.
Move that butt.
Yeah. I wouldn't even. That release is too late again.
All right, go.
3, 2, 1. Yeah!
Yeah! Yeah! Yeah!
What did I say?
Awesome. You should listen to me more often.
Oh, the boss.
Nate.
It worked!
All right, great success.
136 feet.
All right, that's good. That's good.
How the hell did we...
Oh.
Alright, they're gonna try to catch it this time. 3, 2, 1!
It went backwards. All right, rolling.
3, 2, 1.
Oh my God.
What?
Look at that distance. Oh, look at that.
All the way down there.
Nice, nice. This is more like it.
Well done, man.
All right, Josh, what happened?
Nate got lucky.
I have no idea where that went.
Go.
I'm going to be drawing a free body diagram, which would be going down, force of the weight. That's it. And a picture. Well, that's a trebuchet. There's the ball. And it is 9.3 meters above the ground.
Hey, Mr. Willard. How are you today?
I'm good, Chris.
Okay. So this is our best launch with our trebuchet. It had a displacement of 74.07 meters in the x direction. Its acceleration in the x direction was 0 meters per second. The time was 2.875 seconds, and we are solving for the initial velocity in the x. So we're going to plug in one of our motion equations. X naught equals Vox times t plus 1/2 acceleration times time squared. And then when we plug in our values, that ends up equaling 0, so we just take 74.07 meters divided by 2.875 seconds right here. And we come up with a value of 25.76 meters per second.
Mr. Willard, my jaw's starting to hurt from chewing this gum, and it's already lost flavor, so we'll see how it goes. What we did here was we are calculating the initial velocity in the y direction for our trebuchet. So we have a displacement in the y of negative 9.3 meters, acceleration in the y of negative 9.8 meters per second squared, and a time of 2.875 seconds. So we use this motion equation, and once we plug it, it's pretty much a plug and chug problem from here. So we plug everything in, and we get a velocity of 10.85 meters per second. Yes, clapping's not necessary.
Hey.
Hey. Yes, Chris.
Okay, what we're going to be doing now is finding the initial velocity of the baseball, and to do this, we're going to use the Pythagorean theorem by plugging in the velocity initial in the x and the velocity initial in the y. So I will take 25.75 meters per second squared plus 10.85 meters per second squared equals velocity initial squared, and the answer will be 9.4 meters per second.
What? What's gonna happen now?
It's gonna throw a cantaloupe really far.
Locked and loaded there, chained up. That thing. That big weight right there. How much pounds is it? 700 right now?
Yeah, 700 pounds.
700 pounds, wow.
Hear that?
Alright, here we go. 3, 2, 1.
Oh, don't move.
It burst in midair. Did you see that?
Alright, so this is a, we're going to calculate the initial velocity in the x direction for Mr. Greg's trebuchet. We are going to compare it to ours once we're done. So the displacement in the x direction is 198.2 meters. The acceleration is 0 meters per second, and the time is 3.42 seconds. Did I say something wrong?
0 meters per second squared.
0 meters per second squared. So once you plug that into your equation, this will equal 0, and then you solve for the initial velocity in the x direction, which is 57.95 meters per second, which is about a little bit more than 2 times ours. in the x direction. And here's our free body diagram for his and our picture.
Okay, first of all, Mr. Willard, I don't know how you keep gum in that long because my mouth hurts really bad. And this gum tastes disgusting. Okay. I'm miserable. Alright. So pretty much, this is for the big metal trebuchet we showed you. The displacement in the y direction is was 18.2 meters and 0.92 meters. The acceleration negative 9.8 meters per second squared. Initial velocity in the y, we don't know. We don't care about the final velocity in the y, and the time is 3.42 seconds.
Neglecting air resistance.
Neglecting air resistance and heat. So we take this equation and we plug in everything we know for that, and it comes down here, and that equals to about 11.23 meters per second. Initial velocity in the y.
In order to find the actual v initial, you have to use the Pythagorean theorem, a squared plus b squared equals c squared, which would be 11.23 meters per second squared plus 57.93 meters per second squared equals v initial squared. So 3,482 meters per second equals v initial squared. You square root that, and it ends up with 59 meters per second.
Now smile at Mr. Willard. So our initial velocity was 27.94, and comparing that to Mr. Gregg's, his was 59 meters per second, which that makes sense because his is about 2 times the size of ours. He's launching a cantaloupe, which weighs more than a baseball, but his counterweight is also a lot more, which evens out to why his is about 2.5 times ours.
The fish is on the doorstep. Look at his face. Look at
Now we're going to Kim Rao's house. We're going to drop off another fish.